Hello, everyone. Thank you for being here. My name is Sergey Potanin. I've been working for Wrike for 6 years now, and I'm currently working as QA automation team lead. And today I want to talk about how to survive with lots of tests. But what is lots of tests? How many tests is too many? To answer it, we should before answer if they are causing more profit than troubles. And today we're going to talk about reducing those problems. But first, let me spread a couple of words about Wrike. Wrike is a product company which develops awesome web application for product management. It's great for running projects, increasing transparency at work, collaboration, communication, and so on. That's how it looks like. Starting from basics, Wrike has tasks with assignees, descriptions, and communication streams, also different workflows for tasks and projects, which adds flexibility to flows of your work. Also, Wrike has workload view, to manage employees' work and time management on tasks. Then there is a feature called proofing, which allows to review graphical content and much, much more. And since we have such a various set of features, we have to have lots of tests to make sure the quality is good. But before talking about quality, a bit more info about Wrike. Now there are more than 1,100 employees at Wrike. Approximately 350 of them are engineers, and they work among 40 Scrum teams. In QA automation currently are 18 people. Our stack is Java, JUnit 5, Maven, and monthly we have about 100 contributors in automated test project, which are obviously not only from QA automation, but also from QA manual and some developers. Another piece of stack is TeamCity as continuous integration, Aleo server as reporting tool and test management system, and IntelliJ IDEA as IDE. And my examples in this presentation will be about this stack, but all those instruments have analogs you might probably use in your company. But the principles are the same. And what is last but important, we deploy every day. So question, how many tests do you need? I want you to take a moment and try to answer this question yourself regarding your project. And I'm going to answer it as well right now. In my opinion, every tester wants to test everything. So the answer would probably be like that, regression. And the more regression, the better. Then we can test everything. Awesome, is it? Or is it really? And to explain why it is not good, I'm going to show you some numbers. Real example by Wrike. Every day before deploy starts, we run 24,000 Selenium tests. There are all Selenium tests we have right now. Before deploy, we test everything that's ready for deploy combined, and this is the only time we run all tests at once. As every task is prepared beforehand and ready for deploy, the fail rate is pretty low. It's less than 1%. And second line is all Selenium test runs combined. We run every day in average. So from all the builds we run during the day, those are test runs for tasks that are currently in testing. So there could be bugs, broken tests, etc. Therefore, the fail rate is approximately 2 times higher. And again, in average daily, we can have about 250 of those builds. Let's look further. Imagine we run all the tests in each of those 250 builds. Then we would run 6 million tests each day. And with 2% fail rate, it would mean about 120,000 failed tests daily. Sounds like a nightmare, right? That's why we shouldn't run all the tests each time. So we now get why regression could be bad, but how to avoid doing that, how to avoid running so much tests. And let's start with basics. In order not to run lots of tests, you can filter them. And to filter them, you should mark them up. Main Java testing frameworks have this feature by categories in JUnit 4. In TestNG, there is test group field in test annotation, and in JUnit 5, there are tags. But the point is the same. As a result, you can filter tests using these set operations, intersection, union, negation, and grouping using brackets. For example, let's consider this Maven operation. This means run tests which are both not in group API or load, and which are in taxes or model group. So after that, you can flexibly filter any, pretty much any set of tests. But what else can you get by using test markup? So here you can see the screenshot of one of our automated test headers. Some of you probably know these other annotations, epics, features, and stories. So we use epics to point up main big parts of our application. Features are just features, as you know them, and story could be small bunches or similar test cases, or even a single one. And also here you can see annotation type, which we added to technically separate tests, for example, by browser, like Chrome, Firefox, or Safari, or by running group. For example, small tests, small component tests, or it could be screenshot test, and so on. So in our case, we decided that using these tags is too much because we use all these annotations. So we use our custom filter to use only annotation to pick up the group of tests we want to run. Also, every test method a test method we have, we annotate this test case ID annotation to link this test with a case in Allure server. And now what do we get as a result after doing this? This is the same test found in Allure server 3. By adding this markup, we now have structured test documentation. Tests are grouped by epics, features, and stories, and now they could be found easily. But that's not all you can get using Allure markup. Also, Allure framework has annotation called step, which could be placed above each test method, describing what's going on with this method in a human-readable way. You can also pass a parameter in this string, which will be parsed as well. And then the Allure server, there will be automatically formed test documentation that looks like a simple test case in English. So any person who knows how product works are able to read this test. And now you not only have structured documentation, but also a self-maintainable and readable documentation for each test. And this is awesome. So now I want to talk about smoke testing. I bet many of you know what it is and use it. And by smoke tests, I mean a minimal pack of tests that we need to check the very basic and crucial product behavior. I can mention two ways you can mark up smoke tests. First is good old manually picked scenarios. It's a very robust way, but it's very time-consuming. It requires excellent product knowledge and also knowledge of tests you have at the moment at your project. It's hard to maintain, especially if the product is changing rapidly and the number of tests is really large. And here are another approach. Picking smoke tests automatically. For example, to do this in Wrike, we analyzed our code and found the test methods that all the test methods we have and all the steps we use in these tests. Then we found some intersection by picking minimum number of tests and maximum number of steps. Thus, we get pretty good test coverage by smallest test group possible. In Wrike, we use both these ways, but second approach is more convenient and relevant, in my opinion. So how smoke tests could help you to run less tests? After all, smoke tests are just a great way to test possible side effects without running all the tests. For example, if you have a feature to test, it's nice to run all tests marked by this feature and also test to make sure everything else is working properly by running smoke tests. Next, imagine you came to the conclusion that now you want to mark up all the tests, but there are a lot of them already. What to do? So we need to refactor the code, right? And I use different tools for code refactoring, and best in my opinion is PSI. As you might say, using plugin development kit is just to refactor your code is too much, right? But I can assure you that it is worth it. In PSI, you can get all code elements as objects in very convenient abstract syntax tree, or so-called AST. There is an example of problem we used to solve in Wrike a couple of years ago. We have unit 4 categories and wanted to separate them into Allure annotations and our custom type annotation. In the end of the presentation, I will leave links to GitHub repository with the result of plugin we wrote to do so. So let's go further. Imagine you have all your tests marked with desired annotation. Now you have to proceed doing this and never forget mark up a new test, because if you do forget, it would mean that this test will probably never be run with other tests matching your filter. So my advice here is to use PMD. Originally, PMD is a static analysis tool that helps not only keep the code clean and beautiful, it helps to reduce time spent on code review a lot. But it's also a powerful tool to make your own rules. For example, to check each test has needed annotations to be filtered. And more on this topic today among the next speakers, so stay tuned if you are interested. I bet you are. And another person helped us with our problem is my colleague. So there was a problem with code refactoring. So for example, after some major changes, like changing code runner behavior or updating core dependency, you never know what could go wrong, and it's better to run all the tests. But in real life, these big changes are rather rare, so most refactoring changes some part of autotest logic that cannot break everything. So it could be nice to know which tests are affected by changes and which are not. And sometimes it's easy to find out if you changed a method that are used directly in tests. But what if this method is used in another methods, and those methods are used in another bunch of methods, etc.? And a colleague of mine solved this problem for us by writing IDEA plugin for finding affected code. And we use it to find affected tests. Now, after refactorings, we can run just a couple of 100 tests instead of thousands. And luckily, code of this plugin is now open sourced, so you can see how it works and update it for future use of your needs. And I will show you the link at the end of the presentation as well. So here I am about to conclude my short presentation. We discussed how to deal with lots of tests by marking and filtering them to run only needed and to get test documentation, how to pick smoke test packs, and how to run only affected tests after huge refactorings. But I didn't say a word about fighting unstable tests, and this is topic about a topic of great presentation that will be following. So here I put the links to IDEA plugin example to find affected code plugin source code. Feel free to use it and to ask any questions regarding it. Thank you for your attention, and I'm ready to answer your questions. Also, you can contact me directly in Telegram. This is my ID. Don't hesitate to write me later on.